Welcome back, Focused Learners. Let's just jump straight into today's explainer, because we're looking at something absolutely mind-bending. I mean, imagine if your website's codebase wasn't just, a static folder of files sitting on a server. What if it was a living, breathing organism? An organism that could actually detect its own accessibility wounds and just heal them completely autonomously in real time. Well, that's exactly what we're breaking down today, and it's all made possible by the incredible integration of the Model Context Protocol, or MCP, in Claude.
So think about this for a second. What happens when your website's UI is broken, but you don't even know it? For years, the invisible barriers of the modern web, those quiet, frustrating little usability failures that just drive your users away, have traditionally sat there rotting in some endless QA backlog, right? They're out there frustrating users on the front lines, while developers and product managers remain completely, blissfully oblivious behind the scenes. Okay, let's dive into this. When we talk about these hidden usability barriers today, we're really focusing on two main culprits of digital friction. First up, dead clicks. You've probably experienced this. These are user actions, like tapping a button or clicking a link, that result in absolutely no response from the interface. Nothing happens. It's incredibly frustrating, right? And second, and honestly even more critical, are screen reader drop-offs. These represent severe technical barriers in the code. Basically, they force visually impaired users to abandon the page entirely because the site is literally unnavigable for their assistive technologies. To understand how we actually architect a solution for this, here's our roadmap for this explainer. 1. The dead click dilemma. 2. Introducing the MCP stack. 3. Detection, spotting the friction. 4. Reasoning. Claude analyzes data. 5. Application, autonomously fixing code. And finally, 6. The self-evolving web. Let's get right into it. Section 1. The dead click dilemma. Hidden usability barriers.
I really want you to imagine the sheer frustration of trying to interact with a digital tool you desperately need, only to be met with dead clicks. Or worse, encountering code that's structured so poorly that your screen reader simply cannot guide you any further. It's a massive empathy gap in web development. And honestly, it's an issue that has persisted for way too long just because finding these bugs manually is painstakingly slow. So to bridge that gap, we need to think about websites a bit differently. Think of telemetry as a nervous system, feeling pain. When a user experiences a dead click or when a screen reader hits a brick wall and the user bails, our analytics telemetry records that event. Now, historically, websites have had this basic nervous system. They could feel the pain of a bad UI, but they completely lacked the physical ability to react to it. It's like they could feel the burn of a hot stove, but they couldn't pull their hand away. They just sat there and roasted.
Which brings us to Section 2, introducing the MCP stack, the connective tissue.
Now, what's really interesting about this slide is how the Model Context Protocol, or MCP, acts as the breakthrough that finally lets our systems react. MCP is basically a universal translator. It's an open standard framework that allows advanced AI models to securely and directly interact with both your analytics data and your actual local dev environment. So, mapping out the exact anatomy of a self-healing website, we have 3 required components to make this work. First, we need a brain. This is your MCP client or agent. Think Claude Desktop or an MCP-compatible IDE like Cursor. Second, the senses. For this, we're using the official Microsoft Clarity Data Export MCP server as an analytics bridge, feeding live behavioral data straight to the brain. And third, the hands. We need a task orchestration framework, like Composio, which actually gives Claude the ability to interact securely with your front end and push code changes. So we've got the brain, the senses, and the hands.
Moving on to Section 3, detection, spotting the friction. So this is the first active phase of the self-evolving pipeline. It's where the website actually starts acting as a responsive sensory organ. Just to anchor us in the big picture, the entire self-evolving loop consists of 3 architectural steps: detect friction, autonomous reasoning, and generative UI application. Right now, we're zooming in entirely on step 1, which sets the stage for everything else.
In this detection phase, the Microsoft Clarity MCP server is set up to constantly monitor live telemetry. It's acting as that highly sensitive nervous system we talked about earlier. AI agents are just continuously ingesting this behavioral data in real time, and here's the kicker. Without any human oversight at all, the system autonomously identifies exact moments of accessibility friction. It specifically flags exactly where those dead clicks are happening and pinpoints the precise locations in the digital flow where screen reader drop-offs are occurring. The pain is detected instantly.
And that leads us to Section 4, reasoning. Claude analyzes data. Okay, so now that the pain has been felt and logged, the AI brain of the operation steps in to actually make sense of the raw telemetry data that the sensors just picked up. This right here is the absolute core function of the reasoning phase. Claude maps raw behavioral friction to specific UI components. The AI isn't just staring at some high-level spreadsheet of traffic drop-offs. No. Claude parses this granular friction data and correlates those specific drop-off events with the exact pieces of UI code that are causing the problem. By understanding, say, that a certain div tag isn't naturally readable by a screen reader, or maybe a custom button is missing a proper on-click event which is causing a dead click, Claude autonomously formulates accessible design improvements on the fly to fix those precise issues. It's like having a developer actively debugging, but it happens instantly.
Section 5. Application, autonomous fixing code.
And this brilliantly illustrates what happens next. We've detected the issue, the AI has reasoned out the logical solution, and now we reach the thrilling climax where the website physically heals itself. On the left side, you're seeing the before state. Those are the original, inaccessible UI components actively causing dead clicks and those severe screen reader drop-offs. But over on the right side, you see the after state. Freshly generated HTML, CSS, and JavaScript snippets. By using MCP apps or standard file editing MCP tools, Claude generates these updated components to be fully WCAG compliant, meaning they instantly meet strict web accessibility guidelines.
But wait, here is where it gets absolutely incredible. It doesn't just stop at generating code in a chat window. Because we're using task orchestration frameworks like Composio, Claude actually has the hands to take those freshly generated WCAG-compliant code snippets and securely commit them directly into your GitHub codebase. I mean, think about that. The AI finds the bug, it writes the fix, and it pushes the code entirely on its own. No way, right? It's literally fixing itself.
Section 6. The self-evolving web, a new era of UI.
So the crucial point is that we are stepping into a profound new reality here. Websites are no longer just these static digital brochures that require tedious manual maintenance for every single flaw. They can now literally evolve their own interfaces in direct response to human friction. This MCP architecture just completely eradicates the endless drudgery of the QA backlog for product managers and developers. Instead of letting an inaccessible design sit unresolved for months, the system proactively heals its own accessibility wounds the very moment they are detected in the analytics. It fundamentally transforms usability by maintaining autonomous WCAG compliance, which ensures the web remains continuously accessible to everyone, especially those relying on screen readers. It's a real game changer.
I want to leave you with this provocative question as we wrap up this explainer. If a website can autonomously detect its own user friction and fix its own code bugs through MCP and Claude, what exactly does the future front-end developer build? I mean, do we just stop writing UI components entirely? Do we pivot to just building better sensory systems and analytics bridges for AI to learn from? It's a truly fascinating paradigm shift, and it's one that is taking root right now in code bases around the world. Thank you so much for joining me on this deep dive. Keep learning, keep asking questions, and I'll catch you in the next explainer.